Let's discuss question number 42 from test 4. This is from heat transfer. So transfer at the rate of 68 kg per minute is heated from. So basically the water is getting transferred at the rate and is heated by an oil which is the specific heat and rest of the things are given, but it's the basic thing is it's a counterflow heat exchanger. So let's say the oil is entering in this way. Oil is entering inside, let's say. Doesn't really matter for the analysis. The oil enters at 110 and leaves at 75. The water enters at 35 and leaves at 75. So if you just happens to draw, so this is the oil hotter temperature, goes like this, 110 to 75. This is the temperature, this is the length, and this is 35. It reaches basically, so this is how it goes. 35, this is at 35 and it reaches here 75, though I have drawn it very in a very different way, but this is how it happens. So now delta T1 that is the change in hotter to colder is 110 minus 75, which is 35. Delta T2 is, this is basically 75, so the difference in the temperature at the outlet, so 75 minus 35, which is 40. Okay, so the heat transfer from the LMTD approach, log mean temperature difference, is given as in terms of overall transfer UA delta TLM. So this delta TLM is log mean temperature difference, that is written as delta T1 minus delta T2 by log of the ratio delta T1 by delta T2. So how do I find out delta TLM? Well, I need to just do delta T1 minus delta T2 by so delta T1 is, or in fact it doesn't matter whether you do delta T2 minus delta T1 by, because the sign will take place. So delta T1 is 35 minus 40 by ln ln 35 by 40. Okay, so if I just multiply with minus on the numerator denominator, I get 5 by ln 40 by 35. So this value comes out to be 37.44 degrees Celsius delta TLM. So now it's all about finding overall overall heat transfer coefficient. So delta TLM, so we got delta TLM, we know overall heat transfer coefficient which is given in the problem. We need to find out area, but Q, how do I know? Now Q can be calculated from the energy balance, because water mass flow rate is known. So mass flow rate, specific heat into temperature change of the water is basically the heat that is supplied to the water by the oil. So that is mass flow rate is 68 kg per minute. So 68 by 60, specific heat is 4180 in joules per second, and delta T is basically your 75 is the final temperature, 35 is the initial time. So this is Q, and if I substitute everything, so Q, let me substitute 68 by 60 into 4180 joules per second, then this is 75 minus 30 is 40. U is overall heat transfer, which is 320 is given. Area is something which I need to find. Delta TLM is 40, it's 37, sorry, this value is delta TLM, so which is 37.44. so when I do all this thing, I get area, so it's all basically everything is known, you have to just substitute and calculate area. This comes out to be 15.82 meters square. So you have to basically apply this LMTD method. Delta TLM you will get from the temperatures, Q you will get from the water internal energy balance, U is overall heat transfer coefficient, which is given. So it's all there in the problem. So 15.82, answer is C. Thank you.